All right. Good morning to you all. So today we'll be looking into a special type of program where it is an extension of a spinning cube, where the difference between the spinning cube and the rotational cube is, this is the rotational cube which we'll be looking into today. Spinning cube and the rotation cube, we don't have much difference. Only thing is the perspective, right? So in spinning cube, it's all about the orthogonal perspective, which you're going to see over there. And in rotational cube, we look into frustum related sort of perspective. So speaking about the perspective here, so in which axis you're going to see, and will it be a top view or a side view or front view? Those are the perspective which you can actually see, right? So as you all know that there will be viewer, there will be an object, of course there should be light. So three fundamental things in order to make an image fall on, or the image to be captured. Three important things: object, viewer, and light. So anyhow, within the syllabus, the running syllabus, we are looking into the concept of light and its materials. And I thought this is the perfect opportunity to see which will be the best program. So coming back, as you all know that this program is rotational cube, where we actually provide it. We don't actually look into the rotational part or the spinning part here, right? We, in fact, this graphics application is a wonderful application. Usually, we actually, if this is an object, if I say this as an object, the rotation of an object would be in this way, right? Rotation is happening in which axis? It is actually happening in a y-axis. So not, I hope you people can see that. If because y plane will be on the top, this will be the x plane, and this will be your z plane, right? The near and the farther. So if you want to rotate in x-axis, it will be in this way, right? So the object rotates in this way. If you want to rotate in y-axis, it rotates in this way. All right. What about the z-axis? If you want to look into the z-axis, this will be your z-axis, right? So this is your near, and this will be the farther. So the z-axis will be rotating in this way. Okay. So this is your rotation of z-axis. So x-axis, right? Y-axis, and z-axis. That's a wonderful way we have seen previously with respect to the axis in which it is working. And one more thing here is, as I said, most of the time it's all about the object, right? So let's take into consideration, this is an object. This charger, I assume it as an object. Okay, so spinning cube is where, assume this as a cube. Spinning cube is where it keeps on rotating. It keeps on rotating because we have fixed with respect to the rotation angle and the rotation axis. This is actually spinning in y-axis, and if you want to spin in x-axis, so this is how it spins. This is how it spins. And if you are looking into the z-axis, this is how it spins, right? That was with the example of spinning cube. It keeps on rotating. You just need to give an axis of in which axis it has to spin. I think we have some people waiting in the lobby here. I'll just admit them. Yeah. So we have the x-axis, y-axis, and the z-axis rotation. Imagining that this is a cube. The other way is there. It was just rotating. It was just spinning. If I give 1, then it spins around the x-axis. If I give 2, then it spins around the y-axis. If I give 3, it spins around the z-axis. But there was a catch. There was this mouse event, which was actually given. The mouse event actually were assigned, right? So were assigned in the sense, mouse event, if I click the left mouse button, something was happening. If I click the middle mouse button, something was happening. Similarly, if I click on the right mouse button, something will happen. So that was the beauty of that program. Similarly, here also we have the same thing. Why? That is why I'm explaining you here. We'll again look into what exactly happens inside the cases here. Okay, so here we have the mouse event as well as the keyboard event also. So the keyboard event is, I'll explain it to you how exactly the keyboard event is also working. If you press some key, we go nearer, right? We go, I mean, if you people are the viewer, this is the object. If you press X, we go towards the right hand side, right? That means you're moving towards the X axis. So this is an object usually in the middle. If you click X positively, your viewer, this particular object goes on the other side. In other words, object is not going anywhere. The viewer is actually rotating, right? We'll see that also. If you click on the minus, capital X or the caps X, it will shift on the other side. Okay, which is shifting? The object is not shifting. Viewer is shifting. You should be very careful with this. Previously, the object was spinning and rotation. In this particular example, it is not the object which is spinning or rotating. It is the viewer. It is the viewer which we are rotating. For example, if you give a small y in the sense, non-capital case y. So viewer goes on the y-axis top. That means the object will go on the top. The viewer will go on the top. If it is a capital case y, object will go towards the top. That's one beauty of this application. And another one is we also have a Z viewer case of in the Z axis. So Z in the sense the object will, if it is a small z, it comes nearer to you. Okay, so nearer in the sense the viewer is coming nearer. The object doesn't go anywhere. The viewer will come nearer. If it is a capital Z or a caps Z, the viewer will go farther from the object. So that's about the mouse event and the keyboard event in this given application. We'll try to understand clearly with respect to the program. So as you all know, execution starts from main, and in the main method we have some arguments, count and vector. If you are getting any input before the program is starting, then you need the argument count and argument vector. Anyhow, for this particular case of example, we are not using it. The next thing is, this is a 3-dimension object, and we also have, it's a spinning object, right? Spinning application. 3-dimension means always go through the depth buffer, and spinning, that means you need some time for calculating display. So it's always a good habit of maintaining 2 buffers, which will be utilized again and again. And we also use some color models here, colors. So that's where the GLUT RGB comes into picture. So that's what the line 95 say here. The next one is GLUT iNet window size. We have 500 pixels of X and 500 pixels of Y with respect to the window. You create a window with the name of color cube. So that window will be having a name, color cube. Then we use my reshape function here. So my reshape function is one particular function. Whenever you enlarge the window size, or whenever you resize the window, where your window was 500 by 500 pixels, if you make it 600, 350, or 350, 600, that means you are changing or varying automatically. It has to make use of those values from whatever the width which your window has taken and whatever the height which your window has taken, it has to resize it. So that's what there is a function called as reshape function. We'll go there first to my reshape function and we'll come back. So here is the my reshape function. My reshape function will always be going through 2 important values. So one is for the width and the other one is for the height. As you may all know, width is nothing but the window width which we have, right? And h is for the height. Automatically, these two information will be captured by whatever the window size which you are providing, whichever window size you are providing. So the next one is your GL viewport 00WH. As you all know, we have seen about the viewport in our working examples in our session. So viewport takes 4 important values from where to where it has to start. That is important. So where to where it is starting is your X value is 0 and Y value is also 0. So W is the width of your window and H is nothing but the height, for making you people understand much more simple. So this is, let's assume this is a tab here. So this is 0, 0, right? This is your width and this will be your height. That means your complete whatever the window which you have, that will be utilized clearly. Okay, that's about the viewport here. Then we are using GL matrix mode for showing how exactly it works. And as I said, this is one related program which is, we are not spinning it based on the view, based on the object, we are rotating, right? Rotating in the sense, as I said, object is fixed, viewer is rotating, or viewer is going across which axis? X, Y, and Z. For that, we majorly use we go for GL Frustum. GL Frustum. Frustum has a wonderful use, right? So here Frustum also captures 9 particular values, 6 particular values, sorry. One is with I, at, and the other one is up, right? So 3 important values which we will be looking into. So always, whenever I have my width, so that's why we look for one particular example case for if my width is less than height. So this is the other case. Width is actually greater than height, right? So if that is a case, you go for these values, right? These values say something actually, right? If you go look into the function, then clearly you will understand what are these minus values, right? So where you're looking at what position and what I need to consider, those are the values similar to that of your view at and your ortho, right? Ortho 2D or ortho TD. Ortho 3D also had these 6 values. So yeah, if that is the other case, that means your width is now lesser than the height. So you go for this particular values of width. If my width is greater than your height, then you go for these values. All right. So Frustum gives you a Frustum sort of look. If I want to show you in clearly what exactly a Frustum looks, so let me find out something from here. Okay, I have an object. All right, I have an object. So is this object visible for you, guys?
Yes, sir.
Okay, so let's assume that this is an object. If this object is nearer to you, don't you think the object has been increased in size? Do you think or not?
Yes, sir.
If it is far, then the particular object has been depressed or it is a small view. This way of view is what GL Frustum is doing. Okay, so whenever it is an orthogonal, it gives you a fixed look. When it was an orthogonal, it gives you a fixed look. Frustum will give you much more options as that of your case of near and far. You can identify that. Okay, so that's about the GL Frustum. And yeah, whenever you rotate it, the object actually changes its size. I mean, object doesn't look the same as that of your ortho. It gives another feeling that, okay, this is like your real eye view. real eye view. Okay, so whenever you move, it will be retaking the shape. But when that you see in the cube, why? Because the example which we have taken here is a cube. You will be getting it clearly, even though the object which I have taken here doesn't make much difference, because this is some holder, and always, okay, let me take in this way. This is a top view for you guys. So top view. So whenever you spin towards the x-axis, so you're moving it. That means you can see this top, I mean this edge, which has been changing. Okay, so which has been changing. You can see that. Okay, we'll look into that example clearly with the working model. We'll look into. The next thing is, okay, that's about the my reshape method. The next thing is we have something called as display. So GLAD display function, it will show you what are the display features, or this is where your heart of the code resides, right? The logic of the code resides. So well, let's move on to the display function. Before that, it's always a good use. I mean, it's always a you should always use or declare the options which you are using. So here, as I said, I'm using the options of mouse and keys. So I have a mouse function, and I also have a keyboard function which I'll be using. That means you have to provide your the function declaration should happen in the main method. So that's why we declare GLAD mouse function, and the function which you are viewing is mouse. Similarly, if you are using a keyboard function, then you utilize the function called as key. Okay, then we enable the depth test. Why? Because it's a 3D model, and we want it to be like running in a given loop. So we use the GLAD main loop. All right. So yeah, display method is where we go. Before that, mouse and key methods we'll try to understand, because that's the filling here. So we'll go to the mouse function. So mouse function is over here. Yeah. So mouse is actually having 4 information or 4 parameters. So what are those parameters? One is button, state, X and Y. X and Y is where it will capture the position of your cursor. It will capture the position of the cursor. That's why we use the X. That means from left towards how many pixels, from top. With the y-axis, how many pixels. So that's with Y. We also have another 2 more parameters which our mouse function will be utilizing, right? So one is the button. So there are 3 buttons. So which are the 3 buttons? One is left button, right button, and the middle button. So 3 buttons are there in your mouse. And yeah, this is a common mouse again, right? We also have some gaming related mouse which have many buttons also, right? But for now, here it is a small common mouse which we are using. So it has 3 buttons. So 3 buttons are your left button, middle button, and the right one. So we also have a state. State is nothing but you have a mouse pressed and released. In other words, it is down and up. So whenever there is a difference between a down and a up button, right? Because whenever the key is pressed itself, it happens. Sometimes when you release, it will happen. You can also you can make use of it also. Yes, so if my button is left button and the state is pressed, then set the axis as 0. If my middle button is pressed and yeah, it is pressed, then axis will be 1. If it is my right button and the button is pressed, then axis will become 2. All right. So for every time, it has to, you have to move some degrees. That means the object will be there. The viewer should move some degrees. So every axis, for every axis 5 degrees, it will be moved. Okay. So every time it will be moved. And the other one here is if the theta of axis is greater than 360, that means you have rotated you have gone 1 round around the object, right? So once you go around the object, then if it is crossing more than 360, then you have to make it as 0 again. You have to make it as 0 again, right? So theta of axis theta of 0, theta of 1, theta of something, those value will be changing. Those will be changing. Remember. And one more thing, theta of 0 is having some value. Theta of 1 is having some value. Theta of 2 will have some value. Those value will be saving every time, because that state is very much required. Which axis you people are. You cannot reset it to 0. If you reset again, the cube will start from the beginning. I don't want that to happen. I should rotate with the existing value only. So I save those value, and every time you press on any of these button, you will be rotating 5 degrees from the object. If it is y-axis, you rotate in this way. If it is x-axis, you rotate in this way. If it is z-axis, you rotate in this way, like the 0, 1. All right, so that's about the mouse. Let's see about the keyboard. Let's see about the keyboard. If key is equals to small x, that means the viewer 0 will be decremented. Okay, so if key is equals to capital X, the viewer of 0th axis will be incremented. That means viewer distance between will be small or negative with small x. That means the image, the x value will be very nearer. Okay, always remember, whenever you're dealing with x and y axis, you are actually shifting from there. You are actually shifting. Not the object. When you people are shifting, gradually the object may go out the viewport also. Care should be taken over there too, right? See to that the object will be here only. The viewer will be moving around. Whenever a viewer is given, I mean, he has pressed more numbers, that means so nearer, it may also go out of the viewport also. Should take care. I'll show you that explanation here also. Similarly for the Y, similarly for the Z also. Negative Z nearer to the object, capital Z farther towards the object. So these are the, one is for the mouse and the other one is for the keys. I think reshape is now clear, mouse is clear, keys is clear. We'll go back to the main working example of our working case. So that will be the display. We go towards the display function now. So the first thing is you have to create a cube, right? So if you create the cube, only then you can make all those operations. So you have to clear the cube. So yeah, before that, we'll go clearly with respect to the code here. So first thing is clear whatever was there before, right? Clear whatever was there before. Then before that, yeah. So next is clear, give the look at. That's what I said. We have 9 values here. So here the viewer 0, viewer 1, viewer 2 will be with x, y, and z of viewer. The first 3 values are for I. The next 3 are for the look and at, right? So on, in the sense up or down, right? With x and y and z. So x, y, z for these values, x, y, z for these values, and x, y, z for the viewer also. Detailed explanation of glue look at with the 9 values are explained clearly in the session. And okay, before that, yeah, once you make sure that this will be your view, yeah, I, look, and at, this 3 value. Next, we have to go create the particular objects, right? Before that, GL rotate f of theta of 0, 1, 0, and 0. So we have 1, 0, 0 means with the x-axis. GL rotate function of with respect to the y-axis is y value is 1, and rotate function of z means z value will be 1, which you already know, which we have seen in the translation, 3D translation day before. Okay, so these will be the rotation values. The next case is drawing a color cube. First, you need to draw the color cube. We'll go to the color cube function. Here we have. So color cube. We need to draw a color cube. How exactly are we going to draw the color cube? So many things here. We'll take up a paint here, and yeah, let's take here. So we have a polygon with side this, and this. We also have some values which have been given for the polygon. That is this, and for normals we have this. Colors we have this, and this. I'll help you understand how exactly these values have come, including the -1 and +1. It may look very complicated. Oh, what exactly are these, right? So you might see that, okay, why -1, 1, 1? How do I remember it? Very simple and easy way how you can remember this. So first thing is you draw a reference point. Okay, let me take this with the black color, and let's go with the reference point. So I have a small issue we have. Okay, so let me clear this. Basic thing. We'll go to the black, and yeah, we'll start with our object here, which we have. Let me increase the size here. So this will be value of what? This will be 0. So initially, my values, each and every value say something. Each and every value say something. Let's try to see what exactly they say. So we have some values with 3. And first thing is, you know how many values do we have? Exactly like 8 values we'll be having. This is 1. This is the first one. This is the second one. Third one, 4, 5, 6, 7, and 8. Why 8 value? Why 8 value? That is question. Why do we need 8 value? We need 8 value for the 8 vertex in a cube. So this will be my 0. This will be my 0. And for any cube, I need how many? For any cube, I need 8. Yeah, 8 vertices. So this is my first cube. This is my second cube. Okay, 1 second. So yeah, where did this pen go here? Yeah, these are the first 4, and these will be the second 4, right? So let's assume this is our cube. Okay, so every cube will have how many vertices? Every cube will have 8 vertices, and every cube will have 6 sides, right? So 8 vertices and 6 sides. So we have to represent 8 vertices and 6 sides. So that's what we do over here. Okay, the next thing is, yeah, 0, 0, 0 is what we have. The first vertex here is giving me the value of minus, minus, and minus, 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 and minus. So I'll draw the reference line for our understanding here. So this yellow line will be the light yellow, which gives us the reference line. Okay, so this will be the x value. So this will be the x value, and this will be my y value. Okay, this is my origin. Origin is 0, 0. Origin 0, 0. And we have some changes here. So we have to, yeah, this will be minus x. This will be minus y. This will be positive y. And this will be positive x. So nearer will be negative. Okay, so this will be your nearer, that is z-axis. And if you go farther, it will be positive z-axis. Okay, I have drawn with the less contrast color. Why? Because it doesn't look good if everything will be on top. Okay, the first thing is negative, negative, negative. This is what I wanted to show you. What does negative, negative, negative say? Negative with x, negative with y, negative with z. Remember, So this is negative x, that means it will come towards the left. Negative y comes towards the down. Negative z is nearer to you. Negative z is nearer to you. So let's assume this is my first point. Negative 1, negative x, negative y, negative z is over here. So similarly, positive z, positive x and positive y will be where? It will be on the other side. It will be on the other side. Okay, we'll come back. So this is our first vertex, or I'll call it as 0th vertex. All right. So which is the next one? The second one is plus minus minus. So what is this plus minus minus? Where does this come? Plus is with x, minus is y, and z is near. Z is near. Whatever I draw with this color will be near. Okay. Z is near. So blue color is near. Will erase this particular blue for now. Okay. So this is negative x, negative y, and negative z. Yeah, sorry, that was my mom. So x, negative y, and negative z. So the second one is positive x, negative y, and negative z. So where will my value come now? X, down is minus y, and nearer to you will be your z. So here comes the other value. So this I'll call it as vertex 1. So third one is 1 1 minus 1. 1 1 minus 1. So what does 1 1 minus 1 say? 1 1 is positive x, positive y. What does the next minus 1 say? Next minus 1 is actually yeah. So 1 1 minus 1. 1 with x, 1 with y, and this one with minus means negative z. So positive x, positive y, and negative z is, this is nearer. And the other one is minus plus minus. So minus is with negative x, positive y, and negative z. So this will be coming here. So these are the 4 points which are foreground. That means which are nearer. So this will be my 0 1. This will be my 2 vertex. This will be my third vertex. So this will be my vertex 3. Okay. Next thing is your nearer is done. That means negative z is done. Then whatever the values which you get will be with the positive z. That means it is on the other side. So now I'll take the other color. Other color will be this brown for our easier understanding. So whatever you get, the first 4 value will be the front. That means negative. The next 4 will be the positive. That means which will be on the other side. So here, so the fifth position is negative, negative, positive. So negative, negative, positive is negative, negative, positive is negative with x, negative with y, and positive with z axis. That means this is my center line. Positive means it's on the other side. So negative, negative, positive will be somewhere here. That means it is on back side. So this will be my vertex 4. So the next thing is the sixth one. Positive, negative, positive. Positive, negative, positive will be somewhere here. Remember that this is on back of the x-axis. That means on the farther end of z. That is why I'm writing it on the back. So next thing. 1, 2, 3, 4, 5, 6. Seventh one is positive, positive, positive. As I said, positive, positive, positive will be over here. X, Y, and Z all are actually positive. So this case is fifth. This is fifth. This is sixth vertex. Similarly, you can guess it now. This is negative x, positive y, and positive z. That means minus plus plus. So this is where your seventh will be present. So now it's easy, right? How we actually marked it. It's very simple for you. You go with the reverse way. Okay, first you draw the object. I also help you out in understanding that too, how to do that. So 0, 1, 2, 3, 4, 5, 6, 7. These are for the values. Now drawing it in very clear way. So that I'll take it as a black color now. So first, how do you join? That will come back again. Okay. How do we join that? We'll come back to once again. I think this value is now clear. The same thing, whatever you have written here, also clear it for the normal. Why we need a normal is for every vertex we need a normal. Normal is actually some value which will be towards the 90 degrees of a given. It can be a point, it can be a line, it can be a plane, it can be anything. Okay, so this normal will be of the same value which you have given in the vertices. Okay, the next thing is the colors. This is a color cube rotation. Understand, this is a color cube. That means it has good number of colors. So what do I mean by good number of colors here? If I have a cube, all edges are made of colors. So whatever the edges, the first edge is what? As you see here, the first edge is 0, 0, 0. That means no color. That means, can anybody tell me which color it is? If I have 0, 0, 0?
White, sir.
No. If I don't have any color, that means it is black. Okay, yeah. So if all the colors, then it is white, right? Remember the physics example which you have seen. The physics example which you have seen. Okay, that rainbow color which we have, if we spin very fastly, then it gives us a white color, right? So all colors white, no
Yes,
colors black.
Black.
Okay, common sense, right? So you have to brush up with your physics too. The second, the first edge will be black, and the second edge is 1, 0, 0. So this is red. So the third edge is 1, 1, 0. So what is that means the color of red and green. The fourth one is only green. The fifth one is blue. The sixth one is the combination of red and blue. The seventh one is the seventh one, as you can see, red, green, and blue. All colors have been added. That means it will be a white color. Then the last one is the combination of green and blue. In other words, these combination will give you the values which which gives some beautiful colors, right? The secondary colors. Yeah. I don't think we have any doubts from vertices, normals, and colors. Next is about. We'll come back. Come back where? Yeah, color cube, where we started. We go to color cube. So in color cube, polygon of 0, 3, 2, 1. So polygon is over here. So 0, 3, 2, 1. What is this 0, 3, 2, 1? Why do we have to give in this way? 0, 3, 2, 1 or 2, 3, 7, 6. What is it with these values, and what is it with polygon? Why is it accepting those values? Very simple. Get back to your diagram here. Okay. So here we have a polygon with the value what? 0, 3, 2, 1. So where are my 0, 3, 2, 1? 0 is over here. 3 is over here. 2 is over here. 1 is over here. These are the vertices which it knows, right? But still remember, we haven't drawn anything over on the particular display, right? We only knew what are these values. So polygon is where we actually put it into the working. That means you are displaying it. So here we have the polygon. So what is A, what is B, what is C, what is D? A is 0, B is 3, C is 2, and D is 1. So GL begin GL polygon. Take the color of A, color of 0. So what is color of 0? Color of 0 is black. Consider it as black. That's what everything is happening at the same time. Color of black, normal of this value, and vertices of A. So what are the vertices of A? Negative, 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 and yeah, negative, negative, and negative. So that will be your what was that? ABC. Vertex of A. Okay, vertex of A is what? 0. So it will take the 0 initially. As you can see here, it is a begin polygon. That means it will now Draw the polygon whichever points you give. Right, left down will be your black color. From there, it will join 3. Okay, because B is having 3 value. We know here 0, 3, 2, 1. Okay. Yeah, for your understanding. So it went to from A to B, then updated it color to B. That means it is now your red color, if I'm not wrong. Yeah, red color. It updated into red color now. So it updates its color to red and it joins the second vertex. Again, from the second, it comes to the third one. That's what with 1 it is telling you. So it comes to the third one, and then once it sees the end, it loops it back. It loops it back. That means one side is ready. One side of a cube is now ready. Got it? Similarly, whenever I send 2, 3, 7, 6. So 2 is here, 3 is here, 7 is here, and 6 is here. So 2 to 3 it will join. 3 to 7, 7 to 6, and 6 to 2. It joined the second. It joined the second face also. That means you can say this is my phase 1. So this is your phase 2, right? So the other one is 0, 4, 7, 3. So where is 0? 0 is here, 4 is here, 7 is here, and 3. That means it is the left hand side. Okay, so what I'll do is this is I'll draw it with the dotted lines. Okay, I'll draw with the dotted lines because we can't see it, but it is there. It is there. So what I'll do, I'm actually making it as a dot. It is there. Now it created the side 3. Now it created side 3 also. Next, which one is the fourth one? Polygon 1, 2, 6, 5. 1, 2, 6, 5. So this is visible clearly. So I'll draw it. So this is my 5. So 1, 2, 6, and 5 is now drawn. Be very careful. If you give 1, 2, 5, 6, then everything will be messed up. 1, 2, 5, and 6. It will create a zigzag. We don't want that to happen. Okay. Clearly the faces should be given. So this will be the fourth face, and the fifth face is 4, 5, 6, 7. So 4, 5, 6, 7 is here. 4, 5, 6, and 7. So 4, 5, 6, 7 is basically the back end side. So 4 to 5, I draw with the dotted lines. Why? Because it is not visible. Okay. So yeah. So 4 to 5, 6, 7, and loop it created. Then the last one is 0, 1, 5, 4. So what does this 0, 1, 5, 4 say? 0, 1, 5, 4. It will draw it. In other words, we already have the sixth one. So this was the fourth one. This was the fifth side. And this will be my sixth side. This will be my sixth side. So what do we have now? We have all the sides which are drawn. Now it has taken a beautiful side of a cube, right? So once the color cube draws all the polygon, so it is done with the polygon. We'll come back. So color cube is done. Now the first time it will be the same. So now whenever I show it to you, this will be your black, this will be your red. You can just see it, right? Because I'm starting with 0 and this is red. And you can see that. So let's run the program, then it will be beautiful, right? So this is what your color cube actually is. So it is not doing anything. It didn't rotate anywhere. Okay. So what exactly do we have now? So we have
squares.
Yeah, we have a cube, in fact. So we have a cube, but in which form it is? The cube is in which form? The cube is
2D form, sir.
It looks like a 2D, but it is a 3D one. All the other sides is on the other side. I mean, all the sides are on the other side. Okay. Okay. Now
it is visible like square, no, sir, at present.
Of course, You can see the front side, right? So let's now work out with the mouse. So with X, Y, and Z. So I'm now pressing the left button. So just check out. So what is happening when I press the left button? It is rotating on the X axis. It is rotating on the X axis. Any doubts?
No, sir.
No. Okay. So now I'm clicking the middle button. Now it is rotating on the Z axis. Now it is rotating on the Z axis. So when I click on the right button, now I am working on the Y axis. I hope we don't have any issues here, right? You can see the red one over here and the black one, right? So we have the X and Y value. For every click, it is circulating with the values of, it is incrementing with the values of 5. Okay. And we also have the cases of negative X, capital X, small y, capital Y, and small z and capital Z. So I'm going to press small cases of X now. What does that say? We'll be rotating on the X axis. So you can see here. So we are rotating on the X axis. That means the object was rotating, right? Now, when you click on the X axis, the capital X axis, that means you are rotating back. Okay. Similarly, now I am pressing with Y. Now Y axis, you're going towards the Y axis. You're going towards the Y axis. Remember, we are demonstrating in such a way that viewer is rotating, but not the object. So with capital Y, we come back again. Same with Z. So where, as I said, Z is nearer and farther, right? So yeah, this is the thing whenever you go out of the viewport. Okay. So capital S, Z is far, small z is near. This is the beauty of the program of rotational cube. I think that's how the program actually works here. So I think you people have enjoyed it with the session. So we'll be looking into the other code next time.